Hello, my name is Brittany Richardson, and this is my Calculus and Vector CCT. So, what is calculus? Calculus is the mathematical study of change concerning rate of change, slopes of curves, and using the derivative to determine the measure of how a function changes as its input changes. So my question is on page 241, number 2, lesson 4.4, applications of sinusoidal functions and their derivatives. Question 2 says, the voltage signal from a standard North American wall socket can be described by the equation V times T equals 170 sine 120 pi T, where T is in time in seconds and V is the voltage in volts at time T. So this question can be related to the real world by needing to know the voltage going into something that you're plugging in and how fast it's going into it, if there's a specific voltage capacity on something you need to plug into a wall socket in North America. If you're out of a country and you come in and you need to know how fast the volts and how much voltage is going to be coming out of that wall socket, this is one way you could do that. So I'm going to start with question 2a. Find the maximum and minimum voltage levels and the times which they occur. So first, I'm going to take the derivative of the original equation. So we'll do that. So once you have found the derivative, you set the equation to 0. After you do that, you want to get rid of this because you're trying to find cos, trying to get cos kind of by itself. So now that we have this equation, we can use it to find when the max and min occur. So I like to draw a graph of cos. So using the derivative, we know the points where it's 0 are going to be the real turning points. So this is really the max and this is really going to be the min. So this is at pi over 2. This is at 3 pi over 2. So in order to find the times, we must use the 120 pi t and set it equal to where the max and min will be to find and isolate for t. So the max time would be 1 over 240, and the min time would be 1 over 80 after being reduced. So that's the max and min time. Due to the fact that our a value in our equation is 170, we know that that is the max and minimum voltage. So the max voltage is equal to the A value, and the minimum voltage is equal to the negative A value. Therefore, the maximum voltage is 170 volts at 1 over 240 seconds, and the minimum voltage is negative 170 volts at 1 over 80 seconds. So question B is a little more straightforward. It's for the given signal, so the signal that they give us in the question, determined I, the period t in seconds, I will be the frequency in hertz, and I is the amplitude A in volts. So I'm going to start by doing I, the period t in seconds. So we know that the formula for the period equals 2 pi over the b value in the equation. So let's rewrite the equation at the top here. T would equal 2 pi over the b value, which is 120 pi. So T would equal 1 over 60 seconds. So therefore the period is 1 over 60 seconds. The frequency F in hertz. So the frequency formula equals 1 over T, the period that we just found in I. So F equals 1 over 60, which really just equals 60 hertz. So therefore the frequency is 60 hertz. I asked to find the amplitude A in volts. Well, the amplitude from our equation, the amplitude equals the A value in the equation. So our A value is 170. In volts. So therefore the amplitude is 170 volts. Done. Question 2.